Good morning. Okay, guys, let's start. At least you can hear. Good morning, Ralph. Yesterday,
Good
I,
morning, sir.
good morning, Matthew. Yesterday, I gave you one homework. I don't know is there anyone did that one or not. I hope you did it. You practiced at least. Let's do a few more things. 1 second. I'm gonna share my screen. What I want to do today in the sheet? Let me check. It's June 3. Okay, guys, let's do one very interesting thing. That one is called the STP protocol. I want to share my screen. Hopefully, you can see everything. Okay, guys, let me check. Can I see here? I open Cisco Packet Tracer. Now I want to discuss STP protocol. One very interesting protocol is available. That protocol always be available in our switches. Switches means this is very interesting protocol. That protocol, without that protocol, we cannot connect with our network. We cannot work with our switches. So what is that one? Like you can see, these three things are trying to connect. They're trying to connect. When that one will be finished, I will show you that particular things. They're still working. Wait a couple of seconds. Okay. Now it's ready for work. You can see STP protocol always using in our switch, and STP protocol characteristic is when any switch wants to share their information to other place from that side or from that side, whatever that side is, they are always be flirting. Flirting means when these two device wants to connect with each other, switch 0 and switch 1, they are sending messages to each other. That one is common thing. Most of the cases they are using the three-way handshaking. Based with three-way handshaking, they share their informations. Okay, when they will finish, that's good. But when there is multiple devices connected, you can see this device is connected with this one and this one. So two devices connected. So they wants to when they this switch, this left side switch wants to connect with this one and this one. They are doing this one send message, same with this one to send message. Again, this switch wants to do same thing in here and in here. So as a result, you can see always be there flooding their information, always be making one loop. It's never be ended. And always be traffic will be showing in our network. So for this reason, our IT specialist, they are using one type of protocol, STP protocol, and that protocol has one very interesting mechanism. What is that mechanism? You can see in here it's up, in here up, in here up, in here up, in here up, but in here that one is showing as amber sign. Okay, I'm gonna change that. Give me 1 second. Then you can see this side is showing as amber sign. Why the amber sign is showing? Because this connection is close. This side is close. What about the close? Okay, I want to take a screenshot into the snipping tool, and I need to discuss in there, because some theoretical portion we need to check it regarding the STP protocol. I make this one into the snipping tool. Let's discuss that particular things. What happened in here? You can see that this side is cross. Cross means when this switch wants to send any packet to that switch, it's never be goes in here. So that means this one is now close. Close, but that one is connected. It's not moving from that side to this side or that side to this side. So if you want to send any packet from this switch 2 to switch 0, so how come you can go? You need to move like this way. Or again, this one also be sent to this one, so they need to move like this way. It's lots of line. It's taking time. No choice because of the remove the looping system. Otherwise, it's never be ended. The loop will be never be ended, and it's never be finish the work. So as a result, network will be always be closed. We cannot use the network. So how come they said this one is closed? Why not this side is closed? Why not in here? Why not in here? Why not in here? Why not in here? Why this one? So that is one formula for that one. When we'll drag and drop our switches, automatically there will be one MAC address available. In every switch has one MAC address. Based on the MAC address, they will figure out which one will be the boss. Boss in here we are not saying root switch. So we need to find out root switch. So who will be the root? Who is the main boss? Normal sense in the figure, based on the figure, I can say this one will be the root boss. Why this one is the boss now? How come you can know that one will be the boss? So there is one formula for finding your solution. We need to use our MAC address for checking our work. So what is that MAC address? What is that one? Every switch has unique MAC address, and that MAC address will be set that root address. Like, think about this switch as one MAC address. That MAC address is, let me think about, like, I just want to write down MAC address. Think about this is the A, this is the B. Based on the output, I write down like that one. MAC address is not looks like that one. MAC address always be 48 bit, and that one will be use the hexadecimal format. I just write down in here A, B, C, and this A is the lowest MAC address. The root switch, how come we can figure out? Two things, using the two things. One is MAC address plus priority number. This priority number by default in our computer, by default in our switch, they are using, by default, this is the number. So based on switch, every switch has the same priority number, 32,768. So when everywhere is same, so let's check here about the MAC address. So I know we have three MAC address, A, B, C. In between three MAC address, that one is written as hexadecimal format. Which one is the lowest? Lowest is A. A, B, C in between, A is the lowest. A means in the decimal format, this is the 10, this is the 11, and this is the 12. So when any MAC address will be lowest, that one will be the root switch. So that means now we can say this is the root. Root is always represent R, root switch. When this one will be root switch, so in here that port is called designated port. In here it's called designated port. That means root has always be designated port. Designated port means I am the boss. Hey guys, you can use my port. So they are using these two port. And when they are using these two ports, they are called designated port. And who are the connected with this switch? This switch, that one is called root port. This side is also be called root port. So for C, this one is root port. For B, this one is called root port. So we find out this is the main boss. When we find out main boss, done for that one, we have another two switches will be available in here. Think about left side is not available because the calculation is done for left side. Now come back in here. Again, we need to check in between these two switches, B and C, which one is the lowest priority. I can see the lowest priority is this one. So when this one will be lowest priority, same thing, this root port will be now changed with the designated port in here, designated port in here. So we cannot change this one as a designated because that one is the root port, that one is root port. But normal formula is designated port when anyone will be the root. In between these two, this one will be now second root. And this two will be designated port. So if this is the designated port, that one will be the root port. So when second root will be created, in that case, these two are designated port. So apart another side, which switches are available, that one is not root port, that one is called, in that case, alternative port. Alternative port means that port will be close the connection. That port will be now cannot access the network. Alternative, it's not permanently closed. Alternative, why alternative name is showing in here? Because if somehow anyway this switch is not working, immediately this one will be the boss, this one will be work as a root port, this one will be open immediately. We'll check it actually that one is working or not, and the connection will be working like this way. This is the formula for our spanning tree. So when you can see anywhere is the amber sign and anywhere is both are connected up, like this one up and both side is up, that means this one will be the root, main boss, and which one is the cross, that opposite side will be switch will be the second boss, and this one will be used for the alternative purposes. This formula is used for our switch. Why we need? Because we need to stop the flooding, and that switches are now they can configure. So this concept is used for STP protocol purposes. This is purpose for that one. So you can now set any computer in here and you can ping it and you can try to check it. That one will be not showing this way. That one will be showing this way using the address. Now let's delete this one. What will happen? Give me one sec. If you want to delete from the packet tracer this side, what will be happening there? Well, let's think about that one is not available right now. I want to delete it. After a few seconds, you can see immediately that one will be making the connection. Now you can see both are now working. A few seconds ago we saw that one is not working. Now you can see that one is working. Now again, I back into there. We know this is our configure. Let's make add two computers. Just we want to add two computer and when I check it, not in here. That one I have to set in here. Or you can set three computers. Let's make the connection. This one to this one, this one to this one, this one to this one. And now let's do one more thing. Set the IP address. You can set any IP address for your network connection. It's your choice which one you prefer. You can choose. So let's. I'm using any IP address in here. 192.168.1.1. Let's write down in here 192.168.1.2. Let's write down in here 192.168.1.3. Done for that one. Now set the IP address every place. We know that one is our common work. 192.168.1.1. Click in here. Close it. Click in here. Desktop. 192.168. Sorry guys. Okay. 192.168.1.2. Click in here. Now let's click in here. Desktop ping 192.168.1.3. Click in here. Done for everything. I set all the IP address. Let's ping from this computer to this two computer. Go to the command prompt and write down ping ping and write down this IP address 192.168.1.2. Pinging, no problem. Let's ping 3. That one is pinging. Same way, you can try, you can check it. Everyone can ping each other. Let's go to the simulation. Now we want to check it actually. What happened when this PC wants to ping this PC? PC2 to PC3. PC1, PC2 to PC1. Let's use the PDU. Let's set in here. Let's set in here. Now let's play it. What can we see? You can see we cannot go this way. You can see what will happen. It is still working. Wait a couple of seconds. Now it's success. You can see when we're transferring from packet in here to in here, this switch try to go one time in there and this line is closed. When that one is closed, they are not trying another time to use that one. And I check in here. You can see that one is in there, that one is there in here. Now you can see from in here, they will go in there. First time they try to check from in here where I need to move it. They move it in there and they can see that side is not possible to go. Never try anymore using that site because that site already switch 0 give us the message, hey, you cannot come in that place because that site is now closed. Okay, so as a result we can get the output and finally we can see that one is working successful. This is the basic formula for our STP protocol. That's it actually, this lab. So today is the Tuesday. Yesterday we did theoretical IPv6. So today we did STP protocol. So your assignment will be based on this one, STP protocol. So I'll give you one assignment. Maybe I'll change I will add more CPU, or you need to add more CPU, sorry, more computer or more switches, and you need to make the network. So that one will be STP protocol. You can use your network, you can use your work. How come you can design it? Topology is yours. Make your network, make your all the things, and share it into the online. Share it through the our specific location or specific city.mp aggregator. I need to upload this one into the GitHub. If you need anything from in here, you can try to use that one. All the things are available in the online. I already share one book. All the things also be in there. I did in the class. I will share this recording if you want. So lots of resources you have. So at least when you are doing anything, please try to practice it. Everything is very complex. Just I want to give you some hints. We can use this one. We can use this one. This way we are working. That things. Rest of thing you need to practice it. Number 10 will be showing in here. That one is ascending, not ascending order, because this is the one, and after then 1 0 will be come up in here. So if you need, you can check in here. Based on this lab, you have the assignment. So I'm to stop recording. I'll share the recording